Next is interference of light. Yes. So, what do you mean by interference? What do you mean by interference? Before that, I'll explain you one short story. Let us consider that you have a Shant Talab, a silent lake. In that silent lake, you have a green leaf. Somewhere here, you have a green leaf. You have green leaf somewhere here. Okay, and you are dropping one stone. You are dropping one stone. If you drop one stone here, what will happen? If you drop one stone here, yes, what will happen? There will be a formation. There will be ripples, and that ripples will go here. Okay, and once this stone reach down, what you will do? Again, you will take a big stone. You will take a big stone, and you will drop that stone in that lake. Again, the ripples will form, and it will reach at the leaf. See, what's the catch? The catch is, if for the first one, that is for the smaller stone, 3 mm amplitude is reaching, so it will raise leaf by 3 mm. If there would be only big stone whose the waves would be 8 mm amplitude or 5 mm amplitude, so it would have raised that leaf only by 5 mm. But here what is happening? Both waves are moving there simultaneously. We have studied about this in superposition of waves, class 11. This is moving with, let us consider this is 5 mm. So what will happen if just focus on my word, if both crests are reaching, then leaf will move up with 8 mm. If trough are reaching, then leaf will go down 8 mm. If let us consider this 5 mm crest is reaching, and for 3 mm trough is reaching, 5 mm will raise the leaf, and 3 mm will bend will lower down the leaf. So where our leaf will be? Our leaf will be at 2 mm upside. Okay, and what? It will be 2 mm upside. And if 3 mm this and 5 mm this, so what will happen? Sorry, I'll change. If 5 mm this and 3 mm this will down the leaf by 5 mm, and this will raise the leaf by 3 mm. Then what will happen? We will get 2 mm down. That means what? If two waves are reaching simultaneously, then effect of both will be considered together, and that will be explained by principle of superposition. Okay, like that same thing, interference is happening somewhere. So before proceeding for interference of experiment, just understand one more story. This story is an actual story of the great scientist Young Thomson. Young Thomson. Yes, who was Young Thomson? Yes, who was Young Thomson? Yes, he was a he was a great physicist. Okay. Yes, I have heard about it that in the age of 7 years or 8 years, 7 years, he completed the learning of Bible, and till the age of 11 years, he was mastered in more than 11 languages. Yes, he was ENT specialist, ear, nose, and throat specialist, but he was having interest in the optics field. He was researching something about the light. Okay, so one day, what happened? This is a genuine story for the young Thompson. Yes, one day that young Thompson, he was sitting somewhere near the seashore, and he saw something. just a random thing. Okay, yes, this was the actual thing which was which was seen by young Thompson. So I'll show you what he saw, and after that what he concluded. Okay. Yes. See what's there here. We have two sources. First source will produce some wave, second source will produce some wave, and if two sources will combine, there will be an interesting pattern here. See, like this. Just check here. The part brighten up. See, there is a part of like the sun rays. That are the part of that are the part where one crest and one peak had been reached. One crest and one trough had been reached. So it had cut it down the interference of both things. And where we can see the bulging part where what would have happened there, both crest would have reached there. Okay, both crest would have reached there, or both peak would have reached there. Okay, so here what happened, see, I'll explain you once again. See what would have happened. We are taking two same sources. That means if it is 5 mm, this one will also be 5 mm. Okay, if both crest would have reached, then what happened? Yes, we'll get 10 mm up. If both trough would have reached, we will get down 10 mm. Okay, if one crest and other trough would have reached, we will get the zero pattern like this. The part which was brighten up. Okay, this was just the thing which young Thompson was looking at the seashore, nearby seashore. Okay, then what happened, then he came back to his house, and he was actually performing something else not related to this, but he was studying on something. What he did he got yes, he got a room. The room was completely darkened out. If you study physics in higher level, wherever you'll be performing optics experiment, it will be in the dark room. But that time, that this is a talk of 1867, around 1905 something, there was not a dark room. So for that room he used to make a dark. How we can make it dark? See, this is this is window and this is screen. Okay, yes, this is a window and this is screen means this will be wall, but it will be acting as a screen. So what here he will do, what here it will do, here he will have a two, he made a holes with the help of, here he made two holes with the help of, yes, with the help of pin. He made two holes. Okay, and here we have a sources. Here we have a source means light source. Here you have a light source. Anything it can be. It can be anything. I'm not saying it's a sun, it's a light source. Okay. Then everything was darkened out, and this was a slit. This was a source, and here we have screen. See, this is light, this is window, and this is wall. But for our case, it will be source, lit, and screen. Triple S. Yes. So what happened when then he made this room and he went for a sleep. And after in the next morning, he saw some interesting pattern and he was shocked. What he saw? He saw something like this. He saw something like dark pen, bright pen, dark pen, bright pen, dark pen, bright pen, dark, bright, dark, bright, dark, bright. He was completely shocked at why I am seeing this pattern. Why I am seeing this pattern. Okay, then just in a sudden, just in a while, without even having a mentors, his brain started blinking. He was like, okay, this is not a new thing. I have saw this thing in that nearby Shant Talab, that seashore. Yes, near the seashore. See what he saw this part. This part was maxima part. Okay, bulging part. And he saw this part. So he was like, this part of that wave is the same which were here as a bright one, and this part of that wave is the same here as a dark one. So how it would have happened? So he would have he explained that light is in the form of wave only. Light is in the form of wave only. See, from both waves are reaching. If from the waves are there. If one crest and another one trough is reaching, then it will be dark band. If both crest are reaching or both trough are reaching, then it will be what? Then it will be bright band. So when he understood the concept of this interference, he went and he told everyone that Newton was wrong, Huygens was correct. See, this was a talk of around 1867. After 55 years, Young got this conclusion. And what he told that Newton was wrong. And everyone started researching on it again. And then they have interrogation with Young Thomson that how you can say this. Then he gave answer of many of the questions. Okay, yes. Which are the other questions that we will see? See, he was asked first that if you are saying that this dark band, bright band, dark band, bright band, I will get it by with the help of single source, with the help of single source. So what if in the room we have a tube light, and if we and any object we can't see it as a dark band, bright band, dark band, bright band. So our Young Thomson told that it should not be one source, it should be two source. Why? Because see now, see here this slits will be acting as a source only. From their light is coming. So they were like, okay, the interrogation department, they were like, okay, if we have a two sources, if we have this two sources, if we put two sources, then also we are not able to see dark band, bright band, dark band, bright band. Now we will see everything together. So why like this? So he explained with the justification. Okay, he explained with the help of justification. He was like, okay, if you have just a minute. Yes, if you have incense stick, which in many of the language is known as agarbatti. Yes, incense stick. If you have, and if you lighten up that incense stick, and if you just make it round, you will see an entire circle. But it is not a circle now. Why it is like this? Because see, if time is taken less than 0.1 second, then our eyes cannot perceive it. So that's why we are able to see that circle. So even see for the fan also, it is continuously moving. It is moving very fast. That's why we can't be able to see if I'm saying just focus on one blade of the fan. Can you be able to focus on only one blade? No. Why? Because that blade is moving with a high velocity. If speed is high, then your eyes cannot perceive what is happening there. Okay, so he explained the same thing. He was like, if you want interference pattern, so you should follow this condition. His first condition was sources must be coherent. Now I will not repeat again what is the meaning of coherent. Sources must be coherent. Okay, yes. Secondly, he explained that the sources must be monochromatic. Sources must be monochromatic. I know what is the meaning of, I know you people know what is the meaning of monochromatic. Mono means one, chroma means color. Sources must have same color. Okay, then third he told that the distance between, then third he told that distance between sources and slit, then third he told that distance between source and slit, the distance between source and slit should be less, should be less. Again he told, fourth thing, that the distance between slit and screen should also be less. The distance between slit and screen should also be less, should be less. Okay, the distance between slit and screen should be less. Then he told the last thing, that the sources must have same amplitude. Sources must have same amplitude. What is the meaning of same amplitude? That if first one is having 5 amplitude, second one should also have 5 amplitude. If first one is having 8 amplitude, second one should also have 8 amplitude. If amplitude would have differ, then what would have happened? Then there will not be a clear interference pattern. We'll get dark band, we'll get bright band, we'll get dark band, we'll get bright band. But this dark will not be complete dark, and this bright will not be complete bright. So for achieving this interference pattern, we should have this thing. So what is the meaning of interference? Yes, I explained you the concept, but what is the meaning of interference? Interference means modification in intensity of light. Modification in intensity of light when light of appropriate frequency incident is called interference. See, there is a modification of intensity only. If there would be no slit, then everything would be bright, 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 bright. But because of the interference of that slit, what happened? This intensity of dark have completely raised to bright. See, I'll explain. See, if there would be no slit, everything should be what? Everything would be of the same frequency, of the same intensity. Everywhere it would be 40, 50 intensity. Okay, it would be, if it is 40, everywhere it would be 40. But because of the slit, what happened? This dark would have zero intensity, zero, and bright will have 40, then 0, then 80, not 40, because initially it was 40 now. So this 40 had been modified to bright. So this 40 had been modified to bright. So this will be what? This is your 40. Sorry, this will be your 0. This will be your 80. This will be your 0. This will be your 80. This will be your 0, and so on. So the modification in the intensity of light is known as interference. Okay, so this was the interference pattern, which was explained by Thomson. Let's see some questions based on this. The first question: the phenomena occur when two or more light waves overlap, leading to reinforcement or cancellation. Is what phenomena occur when two or more light wave overlap, leading to reinforcement or cancellation? The phenomena is known as what? It is known as diffraction? No. No. Reflection? No. It's interference. Okay, it would be reinforcement. That means it would be either the maxima or it would be a minima. Yes. In Young experiment, what is used to produce two coherent light source? What is used to produce two coherent light source? We use double slit. See that, check that pinholes double slit. Okay.